In this tutorial, we take a look at how to rig tank treads. The method shown here is one of many. It uses a workflow based on path constraints and a simple script that you will need to write. There are more sophisticated methods to rig tank treads, but they usually rely on more complex scripts. Some other methods rely on IK solutions and, while powerful, are often too heavy to compute. The scene you will work on shows an all-terrain vehicle. There's already one tread element in the scene that you'll need to duplicate and place on the provided path. Although this example deals with tank treads, you can use the same technique to build bicycle chains or escalator steps. Basically, you can use this technique with any elements set to travel along a path. The basic approach is pretty straightforward. First, you need the helper object to travel on the path. Create a dummy object somewhere in the scene. The dummy will be used as a master object for all treads in case you need to edit their behavior later. With the dummy selected, choose Animation Constraints Path Constraint. A rubber band appears. Click on the path in the viewport. In the motion panel, enable the Follow option to make sure the dummy stays oriented in the direction of the path. If you scrub the animation, you'll notice the dummy traveling backwards. This happens sometimes depending on how the path was created. To fix this behavior, you need to reverse the path. Select the spline and go to the Modify panel. Go to Spline Subobject Mode and select the spline again in the scene. It should turn red. In the Geometry rollout, click Reverse. Exit Subobject Mode when done. Test the animation again. Now the dummy is moving forward. Next, you place the tread on the path to match the behavior of the dummy. Select the tread. Notice its name, Box 001. Rename it Tread 001. To place it on the path, you can repeat the procedure you did with the dummy, or you can copy the dummy position controller onto the tread. You can do that using a simple line of script. Right-click in the bottom left corner and choose Open Listener Window. Select and delete all the existing text in the white area. Type in the command $tread001.pause.controller equals copy $dummy001.pause.controller. This line of code is very easy to understand. It is basically saying that the position controller of tread001 is to be a copy of the position controller of the object named dummy001. This copies the controller and all options that go with it, including in this case the enabled Follow option. Close the listener window. At this time, the two objects seem to be moving as one, but their position on the path is still independent. One object could easily have a different path percentage and therefore be on a different path placement. To make sure the two objects are locked together, you will wire them so that the percent value of the tread is always equal to that of the dummy. Select the dummy, right-click it and choose Wire Parameters. Wire the Transform Position Path Constraint percent value to the same value on the tread. In the parameter wiring dialog that appears, ensure the link is one way from the dummy to the tread and click Connect. Close the dialog when done. Now you will notice that the tread's percent value in the motion panel is grayed out. It can now only be controlled by the dummy's percent value, making it dependent on the dummy's position. The trick now is to make additional treads, each subsequent one depending on the position of the previous one. You will basically need to offset them slightly to create the chain. You will need to automate that process, but first, let's take a look at the math behind it. Make an instance of tread001 using Edit Clone. At this point, both treads are in the same spot. Make sure tread001 is selected. Use the H key to select it from a list. Wire the position path percent value of tread001 to the same value in tread002. You will need to press H to select tread002. Make the wire direction one way from tread001 to tread002. Change the expression to read % plus 0.1 and click Connect. 0.1 represents 10% of the path. Notice the new position of thread 002. Try % plus 0.03, 3% of the path, and click Update. The two threads are now closer together. Keep trying different numbers until the two threads fit together. A value of 0.015, 1.5%, ought to be close enough. Scrub the animation. Notice how the threads move based on the established relationships. Now that you have the offset value set, let's see how we can create the chain. You need to make a number of instances, wire an instance to the preceding thread, and set the expression with the offset value. If you were to do this manually for 60 plus chains, you'd be spending a lot of time on them. Close the wiring dialog box and delete thread 002. In the next movie, you'll learn how to automate the thread creation process.